So this lesson is on multiplying radicals. When you multiply the radicals, you want to essentially multiply the coefficients. That's the numbers on the outside. So multiply coefficients. And then we want to multiply the radicands. Those are the numbers on the inside. And then we always want to make sure our final answer is simplified. So we'll simplify at the end. So there's a couple of shortcuts you can take when you're doing this. Let's look at number 1. On number 1, we're going to be multiplying these numbers here. So look, we're going to multiply the numbers on the outside, which would be these two. And we're going to be multiplying the numbers on the inside, the radicands, which would be these two. So we're going to do negative 2 times 3, which would be negative 6. But then we're going to have this square root of, and instead of doing 20 times 5, which we say is 100, we're going to leave it like that because we actually are going to have to do the prime factorization of this. So let's go ahead and do the prime factorization of 20 times 5 is essentially what we're doing here. So what's 20? 20 is 4 times 5. And if we look at 5, that's itself. So that one's already, we've got the prime factorization of the number 5. We're just going to do the prime factorization of 20. 4 would be 2 times 2. So now, all of these numbers multiplied together would give me 20 times 5. Because here's 20, 2 times 2 times 5. That's 20. And then we have times 5, which is this number here. So look at this. We're going to take that negative 6 down, and we're going to go ahead and put our radical symbol here, and we're going to go ahead and write the prime factorization here, which would be comprised of 2 times 2 times 5 times 5. What are we looking for? Well, this is a square root, so we're looking for twins, or sets of 2. So 1, 2. And remember, when you pull it out, you only get to keep 1. So one of each comes out. We have a negative 6 on the outside. We're going to now pull a 2 on the outside, so we're done with that. We're going to pull a 5 on the outside, so we're done with that. So now we're ready to multiply. 2 times 5 is 10. 10 times negative 6 is negative 60. And that would be my final answer for this question. If you look at number 2, same idea. We're going to be multiplying the numbers here on the outside, the coefficients, and we're going to be multiplying the radicands together. So 4 times 8 is 32. Square root of, I'm going to go ahead and say, I know that 42 is made up of 6 times 7. And I know that 35 is comprised of 7 times 5. And so if I think about 6, you're like, oh, you can break that down more. Yes, that's true. That's 2 times 3, but that wouldn't make me any twins in here. So I'm ready to go. So I have 32. I'm going to take this out, one set of 7s out, so only one comes out, so 32 times 7. And on the inside, I would have 6 times 5, which, there's a prime number, not prime, there's no twins in it. So we have on the outside 32 times 7, which would be 224, square root of 30, which cannot be simplified anymore because it has no sets or pairs left with it. All right, so then my final question here on this page, you gotta be careful. When you see something square, what does that mean? Well, it means you take that and multiply it times itself. So we're going to multiply the numbers on the outside. That would be 3 times 3, which is 9. We're going to multiply the numbers on the inside. Watch this. I'm going to cheat. I'm going to do 8 times 8, which is a pair. I don't even have to break that down. I see it's a pair, so I'm going to pull it out. So I already have a 9 on the outside. I only get to keep one of those 8s. I'm done. Nothing's left on the inside. So 9 times 8 would be 72, and that would be my final answer here. Sometimes we try to get a little tricky on you. Well, let's look at number 4. Number 4, we've got fractions, but don't dismay, because look what happens when we combine them. Everything on the numerator gets to stay in the numerator, so that would be like 7 times 7. Hey, look, that's a pair. Everything in the denominator gets to go together, which would be like 2 times 18. Now we can break this off and do the square root of 7 times 7 over the square root of 2 times 18. Now, I can already see that I've got a pair of twins, so I can pull out one of those 7s. But what about this 2 square root of 18? We should figure out what that would simplify to be. So let's do 2 times 18. Well, 2 is already prime. 18 can be done by 2 times 9. So I have a prime number here, and 9 would be 3 times 3. So if I put all of these under the same roof, what I'm really working with is 2 times 2 times 3 times 3. So let me rewrite this so it makes a little bit more sense for you. On the top, I have 7 times 7. I haven't done anything with it. On the bottom, I'm replacing this with this down here. So it's 2 times 2 times 3 times 3. And now I'm looking for twins. So here's a set of twins. That's going to come out. Here's a set of twins, that's going to come out. Here's a set of twins, that's coming out. So I only get to keep one of each. So I take 1 7 from the top, done. 1 2 from the bottom, done. Times 1 3 from the bottom, done. And I'm out of stuff on the inside. So I'm just going to simplify this. That would be 7 over 6. That's it. That's my final answer. Now in number 5, you got to be careful. You see the parentheses? That means we've got to get that distributive property going. So we are going to distribute that square root of 6 to both terms on the inside of the parentheses. So square root of 6 times 3 is going to be 3 square root of 6, because we always want that coefficient, the number in front of the radical. And then we take the sign, so minus square root of 6 times square root of 2. So we multiply it times a 3, that's what we got. We multiplied this times a 2, that's what we're working with right now. Now, if we do the prime factorization of 6, look at what it gives me, 2 times 3. So that's not a twin. This is as far as I can go. That would be 3 square root of 6. However, let's look at this idea here, because we have essentially like a 1 here and a 1 here, and you multiply them, they still give you a 1. So what if we put the 6 and the 2 under the same roof? I know that 6 is comprised of 2 times 3. So 6 I'm going to replace with 2 times 3. That's 6. Don't forget that too. Hey, look, there's a twin here. So if I take this guy and this guy out, how many do I get to keep? I only get to keep 1 on the outside. So I have minus, I'm getting that from up here, and then I'm taking one of those 2's, and what's still inside? 3. Now, are these like terms? No, the radicands aren't the same, so this would be my final answer.